Yep. I assume that's probably a chat. I've got too many things open. I can't see the chat. So if you got anything for me, please just get it on out here. Uh, or if it's something you don't want anyone else to see. Oh, here comes Diana. So I'm going to admit Diana. All right, now we're up to 22 students, I think. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 21, 22. Got it. Okay, so we are now recording. There was a question before I started recording on what was due, and it's always out there under the each week on the weekly activities, week 1, week 2, week 3, week 4, every week. Under that very first thing under there, it says, well, I just called what it is, sort of like an overview and weekly to-do list type thing. The very first tab under each week, and it has an overview and talks about what sections we're going to be covering, what objectives we're going to have. This is all garbage they make us put out there. And then at the very bottom is the weekly to-do list. Read the section, study the section, work these exercises. Read the section, study the section, work these exercises, blah, blah, blah. And then the very last one says submit at least one homework exercise, especially any that you're having difficulty getting the correct answers, because all the exercises are odd number exercises. They all have their answers in the back of the book. They're all available at calcchat.com, and some of them are available at calcview.com. So you have lots of opportunity there to figure out what you, if you can't get the right answer, what might be the problem. And if none of that seems to help, those are the problems I want to see, and we'll go over those in class. Now, if you aren't having trouble getting answers, then just send me a problem. Just one. That's all I need every week. Not one a day, one a week, okay, from that homework. And if you haven't done some of those in the past, you can always go back. But I do ask you to do this. Please put your name on the problem, because I'll get busy printing a bunch of them off and then realize when I start organizing them, this one doesn't have a name and I don't remember who sent that problem, and then I have to go through my deleted folder. It's really hard to recreate who did what. So please put your name, and if it is one making up for a previous week, and probably a good idea anyway, put the week. Put this is week 2, week 3, week 4. We're now in week 5. So if you are going to catch up and do some past ones, then please put the week also. In fact, that's a good idea to do anyway. Put your name and put the week with the problem. Or problems. If you're having trouble getting the answers on any of the problems, send me those, because those are ones we can do in class. Or if it's just something simple and you and I can work out either on email or on the phone or with a little Zoom session or something like that, we can do that too. So I won't be saying who had problems with it. I'll just say, student sent me this one, looks like a good problem to do. Okay, Daddy is coming in. Does anyone know who Daddy is? I'll let Daddy get connected to audio and I'll ask who Daddy is. Must be using this son or daughter's computer or a phone or something. Okay. Jakara, you got something for me, or you just lit up? Okay, Daddy's in. Could someone tell me? Okay, who's Daddy? You were just in here. Okay, who is it again? One more time. Oh, got it. Ladarius, got it. Okay. Daddy Ladarius, got it. Okay. Boy, the bottom part of the alphabet is here in great numbers today. Top part's not doing too bad either. In fact, this is a really good attendance day. 23 students here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 1, 2, 2, 23. That's very good. Hope the rest of them show up. We're only missing, there's some people that haven't been here at all. Briantra and Rattray. I think that's all. No, one more. Chance, Briantre, and Rattray. Top part of the alphabet is quite good. Bottom part is really strong. That middle part has a few gaps in it. But way to go, folks. Good to be here. All right. Yes, what's the question?
So this weekend, well, yeah, this weekend I was trying to like turn in like the. I know it's been a while, but like the syllabus thing, like when I clicked on it to like try to submit a thing, like it wouldn't let me
Okay.
like submit the syllabus acknowledgement form,
Yeah.
and
Did it say why it wouldn't let you?
no, you know how like Facebook goes, like it opens up, like when I click on it, opens up and say you just submit it here,
Right.
but like when I click on like a different thing to like upload a file or
Right.
save it to my computer,
Right.
like it doesn't let me. It's only saying that you can insert like a week or insert like something else, not like something from my computer.
Right. That's Blackboard, and I don't understand the intricacies of Blackboard. I don't understand why it does some things some way and some things another way. It is one of the more confusing packages I think I've ever had to deal with. I have trouble figuring out how to get things. So if you can attach it to an email, send it to me that way. If you can attach it to a message in Blackboard, send it to me that way. If it's not working on the thing, I'll give you an example. Every week, I think I've got them in there, every week, where it used to say weekly assignment, that was something they had for online courses. They made us use this online platform for virtual classes, which doesn't fit well. So I changed weekly uh, assignment to homework. Uh, uh, week one homework or something like that, or weekly homework or something like, yeah, week one homework, week two, no, week two homework, week three homework, that kind of stuff. I changed it to read that. Now, when I did that, then I was going to put that statement out there, please submit at least one problem, blah, blah, blah. In some of the places, it wouldn't let me put that statement there. Okay? Whoever did the template forgot to put the little plus symbol that allows me to put something there. So I had to put it, in fact, everything in Blackboard, you have to put about 2 or 3 different places. That's why I know I can put it on the weekly to-do list. It'll always be there. If I can, I put it on that one that says week one homework, or week two homework, week three homework. The week one homework basically is either the uh, acknowledgement page or it's the research paper topic. Sometimes it went one place, sometimes it went the other. That was back when I was just learning this, so I wasn't sure how to get all that to work. If you can't get something to load, don't feel like the Lone Ranger. I haven't been able to get things to load either, and I'm supposed to be able to. And whoever did it, they did it in a rush, and they didn't they didn't leave very many. Chance just came in, so boy, we are great attendance today. Uh, just missing 2 people. That's Briantra and Rattray. Okay, I hope I'm pronouncing his name right, but he's not here to correct me. So anyway, um, excellent attendance. So if you can't do it one way, send it another, and that's why I leave all those options open to you, because guess what? This is such a confusing system. I am so sorry. I wish they let us do it the way we used to do it, which everything was out there in one place. There weren't all these layers and layers. I think someone complained about that earlier, that you have to fight your way through and then you can't remember if you got them all done or not. I'm in the same boat. Every evening, my wife complains so much. After supper, I have to come up and get everything done in Blackboard for the next day's class, and it just eats up time like crazy. So sorry. Yes, what's that?
Okay, and this may be sound like a rhetorical question, but I just want to ask for clarity. If you have just a hypothetical, just say a C for your attendance, because you missed so many days, and as time goes on, does that average ever changes, or is it always going to remain at a C?
Okay. Somebody else had a similar question earlier. I'm trying to remember who it was. I answered by email last night when I was trying to get things straightened out. I know he's in the class now. I just can't remember who it was. But that is another stupid Blackboard artifact. I tried to get it so all it would do a letter, P or A. And what did it do? It gave a percentage. Okay. I don't have anything to do with that percentage. I didn't do it. I have a guess of how they calculated it. I don't really care. And then they assign a letter grade to it, like you're talking about. That doesn't matter a bit. Okay? They keep telling us all that requires is performance. Okay? Not attendance. Now, we want you here because I think that will improve your performance, but guess what? It's not what you're graded on. So that is a completely meaningless Blackboard artifact that I have absolutely no control over. I put the attendance in, it decides to put whatever out there it did. Last term when I think it was last term when I was using, it may have been in the spring, first time using this Blackboard Ultra, it decided it wanted to average my grades for me. And I don't know how in the world it did it. He gave some of the top students in the class who had the most points in everything F's, and had some people who had hardly turned in anything with A's. And how Blackboard came up with that, I don't know, and it really didn't matter to me. I found a way sort of to turn that off. I've not been able to figure out a way to turn off the attendance grade that it's imposing there, but it has absolutely no impact on your grade except for this. If you're here, I think you're more likely to pick up the material because we go over it in class, you get to ask questions. So in that sense, we really want you here so you can get the best benefit out of the class. But what Blackboard puts out there, absolutely no meaning whatsoever to me, to anyone else. Now, one thing I do like about it, it gives me up in the upper left corner what the percentage attendance is for the class for the term. And I like to see that when I see 24 out of 26 people here. Yay, y'all are doing really well. But I'm just proud that y'all are here. But it has nothing to do with your grade. Is that what you're asking?
Yes, you answered.
Right. And more than likely, as you keep coming, hopefully the percentage will go up and the score will go up, but it means nothing. Okay. Please be here every chance you can. That's the point. Now, let me say this while I'm thinking about it. In my second class yesterday, I had one of my students, he happens to be one of the baseball players at Lawson State. He told me he was the first one in. He said, well, I said, "Oh, you here earlier?" I mean, just made a little joke or something. He's been in my class before, and he said, "Yeah, I don't have anything else I can do. I got tested positive." So, and he said he did have a sore throat. He had a little bit of a headache, a lot of drainage, a little bit of a fever, and sure enough, he tested positive for COVID. So please, folks, it's not going away. It's out there. And now he and his roommate, who's also a baseball player, even though the roommate is not, and they're saying socially distancing apart within the apartment as much as they can, he's staying in his bedroom just about totally. And the roommate's even doing the cooking for him and stuff, and he cleans up anytime he has to go out. But his roommate's quarantined also. So, folks, it's there. Do not mess with this. It's. I don't want to say this, but it is true. It's a killer. But even if it's not a killer, it can really make you sick. And fortunately, it sounds like he's in not too bad a shape. So he's having a fairly mild case. I've heard of several of those, but other people have been down and down hard. One of our instructors' wives is really, really sick. Their son brought it home from school. she got it, and now he has some symptoms, but he's caretaking for her. I don't know if he's been even tested yet, but it's just it's a bear. So don't mess around with it, people. I thought I'd get that in there while I could. All right. Anything else before we actually start? I do have one more thing I need to do. Um, it's going to take me just a second to do that. I wanted to get 1.6 open so that when we finish 1.5, it'll be there. Okay, there's 1.6. Okay, let's go back to Zoom. Any other questions, concerns, issues before we get going on math today? All right, then I'm going to start the share here, and we'll do 1.5. That's where we are. Unfortunately, it's not on the slide that we should be on, so let me scroll down and get that. We're on zeros of a function. Okay, and we're on example 3, and I think we're on the B part. So that looks like maybe it's right here. I think this is where we ended last time. Okay, now you can't see that yet, or maybe you can. Can you see that? Example 3, solution, blah, blah, blah. Okay, what I'm going to do is move this taskbar. You can't see, but it's right in my way. And we'll start from the slideshow from the current slide. Now, this is indicating that you can, this is being shared. Can you see example 3, solution number B? Anybody?
Yes.
You can, good. All right. Now, actually, here was B, here. Find the zeros of each of these functions. Here's the one they're asking us for here. Now let's do a little quick review. I know it's been several days. So what do we mean to find the zeros of a function? Anyone have a guess? A suggestion? A recommendation? What does it mean? Yes. What do we do? Well, I thought I heard somebody, but okay. What it means is zeros of the function. You set the function, which is g, which is square root of 10 minus x squared. There it is. It's just the square root of 10 minus x squared. To find it 0, you set it equal to 0. The function equals 0. G of x equals 0, so that makes this equal 0. Okay? Now, what we do is find the x's that make that true. How would you suggest we do that? The square root sign? Yeah, the square root sign, the radical. How do you undo a square root? Okay, you square it, okay? And when you square a square root, you lose the square root sign, so that gives you 10 oh, is someone coming in or is someone sending me a message? Nope, I don't see anyone else coming in. Okay, that thing pops up every now and then. I always like to check to make sure I'm not leaving somebody out. So when you square this, you lose the square root and just get 10 minus x squared. And of course, when you square 0, you get 0. Okay, so it's sort of like what you first said. You get rid of that radical. Since it's a 0 on the other side, that's exactly what it looks like you did. Now what?
Would you subtract 10 from both sides?
Yes, you could do that. I'm more inclined to add x squared to both sides. Are you okay with that? Is that legal too in most states? Okay. Okay. Now the reason I did that is so these go away, and that gives me, now I'm going to swap sides again. X squared is equal to 10. Now if we'd have done it your way, which is perfectly fine, we'd have been at the same place, except it would have said minus x squared is equal to minus 10, and then you have to change signs. So I'm just really lazy, and this screen is hard to write on, so I just do as few steps as possible. I just added the other one and then swap sides. Now, how do you solve that? We're not really interested in what x squared is. We want to know what x is. And let me do a timeout here for just a moment. Whenever you square both sides of an equation like we did back in this step right here, okay, you always have to be very careful and check your answer and make sure it makes sense. So at the end of the problem, we want to make sure our thing makes sense. So remember that. Anytime you square both sides of an equation, you better check your answer. You may introduce what they call extraneous roots, things that look like they solve it, but really don't. So therefore, on this one, we really need to check our answers. Not a bad idea anytime, but this one we do. So back to this question. How do we undo a square? Anybody? It's kind of reverse of what we just up here. Not divide. That would be if it was multiplied. You undo multiplication by division. How do you undo a square? Not subtraction. Subtraction undoes addition. Okay? How do you undo a square? Absolutely. Take the square root of both sides. The square root of x squared is just simply x. But when you take the square root of both sides, this time you have to remember always to put a plus or minus. You always have to put plus or minus the square root of 10. Now, unfortunately, 10 is not a perfect square, so you're going to have to leave it like that, an irrational number. And this is the place where we go back and plug this in, this value for x in, to see if it works. So let's do that. Let's see what g of positive the square root of 10 is. Okay? That would be the square root of 10 minus the square root of 10 squared. Okay? Well, the square root of 10 squared, the square undoes the square root, and you got 10 minus 10. Sure enough, that gives you a 0 for the function. That's what we were looking for. Let's do the other one. I'm going to do it down here. If I can get my pen to get down that far, there it goes. Get out of there. Okay, g of negative the square root of 10. Okay, and that's equal to the square root of 10 minus negative the square root of 10 squared. When you square a negative, it becomes positive. So, and then you square a square root, and you lose the square root sign, and again you get 10 minus 10. Yes, that 0, that works. So this time you didn't introduce any extraneous roots. Both of those are your answers. These are the two zeros of this function. Positive square root of 10, negative square root of 10. Now I think in the slide set they may show you the graph of this. I hope they will. Let's advance ahead and see if we can find that. Okay, there was the A problem we did last time. There were the two roots of that one. And then here's this one. Okay, so how do you find the 0 of a function? Set the function equal to 0. That's what it means, the 0 of the function. So you set the function, square root of 10 minus x squared, to equal 0. Square both sides, and that gives you 10 minus x squared equals 0. And then they did the same thing I did, but it would have worked just as well to do subtract 10 from both sides. Like you said, that was perfectly correct. You just have an extra step there. They're almost as lazy as I am. So they added x squared to both sides, and they got the same thing. X squared is equal to 10, and then they took the square root of both sides, and that gave you, they left it on the other side, plus or minus square root of 10. Anytime you take the square root of both sides, you have to do a plus or minus. Anytime you square both sides, you better check your answers to make sure they both work. Those are just things. Adding, subtracting, multiplying, dividing, usually you don't introduce anything that would be weird. Okay, so those are your two potential solutions. Here is what your graph looks like. I was hoping they were going to do this. This is a semicircle, okay? A semicircle that ends at minus 10 and minus root 10 and plus root 10. And by the way, that's something a little bit greater than 3. Square root of 10 is a little bit greater than 3 because square root of 9 is 3 and the square root of 16 is 4. So square root of 10 would be closer to 3. So it's either minus 3, a little bit more, less than minus 3, a little bit greater than positive 3. And that's your semicircle. Now you might say, how do you know it's a semicircle? Well, I'm going to ask this question. What is g of x? Now usually I ask f of x, but same thing. What is g of x? This is one thing you're supposed to remember from the course. G of x is equal to y, just like f of x is equal to y. G of x equal to y is equal to the square root of 10 minus x squared. So you see when you're plotting this, this y is what your g of x is, okay? Then square both sides, you get y squared is equal to 10 minus x squared. Add x squared to both sides, you get x squared plus y squared is equal to 10, okay? That's the equation of a circle who's centered at the origin, and sure enough, there's the center right there at the origin, and whose radius is the square root of 10. And sure enough, that's what it is. Except this isn't a whole circle, is it? This is a semicircle. What if you had the whole circle here? I didn't draw it too well. I don't draw circles well. Something like that. What would have been wrong with drawing that? Anybody? This is supposed to be a vertical line. What do you notice about it? Intersects two places. Can't have that. This cannot be part of the solution. Otherwise, it wouldn't be a function. For this to be a function, g of x is equal to this, you have to either have the positive half or the bottom half. And that's why when you don't see a minus sign here in front of that square root, you know you're on the top half. If that had a minus sign there, you would have been on the bottom half. But you would have had the same through zeros of the function here and here. The rest of these are not zeros. Okay, I beat that into the ground. Is that okay? Now, here's something else to note. The zeros of a function, when you do the graph of the function, those become your x-intercepts, because that's where y is equal to 0, y is equal to 0 anywhere on the x-axis. So your zeros of the function, that's another way of saying they are your x-intercepts. Now is that just a lot of blah blah blah, or does that make sense? Anybody? A little bit of both. Sorry about that. Okay. Any questions before we move on to C? In fact, I think to do C, let's move back to C. Now, the trouble is I can't erase what I've done now. Not on this slide. I can on the whiteboard. How do you think we're going to find the zeros of this function, h of t? Real simple first answer. How do you find the zeros?
You set it equal to 0.
Perfect. Set it equal to 0. Now you've got a question. Okay? Now, okay, let's do a timeout and go back to B again. Remember here, we didn't specify our domain. I think they should have. Okay? Of this. Okay, of A, no limits on the domain. All real numbers. That works fine because that's a polynomial function. This one's a square root. And remember, the domain of this one is that 10 minus x squared has to be greater than or equal to 0. Right? You can't take the square root of a negative number. Okay? So what we saw in our graph here, if you work that out, and basically you do almost the same thing we did down here when we did it, we would have had that 10 is greater than or equal to x squared, and then you have x squared, I'm going to reverse them, is less than or equal to 10. Now, there's a temptation here to take the square root of both sides, but that doesn't quite work here. I mean, it does. That's where you get your root 10, but you have to be careful about your inequality here. This is a directional inequality, so there's two ways this could happen. And you can go back and see how we did that before, but here's what the graph showed. Let me go back and show this. Notice here, the graph they had here, it's x has between minus the square root of 10 and plus the square root of 10. That is your domain, and that's what you got from that inequality. The 10 minus square root, the square root of 10 minus x squared has to be between those 2 points. And that's what you would have gotten from this. So therefore, these are your two x-intercepts, your functions in between those, nothing on the outside. So your domain was only that. Now the reason I mentioned that is this problem has sort of the same issue. We do have a domain issue. What can the domain never be? What's the other thing you can't do? You can't take the square root of a number that's negative, and the other thing you can never do is divide by, help me somebody. What can you never divide by? Ever. Zero. So therefore this denominator, t plus 5, can never equal 0. Now this is a simple non-directional inequality. All you have to do here is subtract 5 from both sides, and you get that t cannot equal negative 5. Okay, just keep that in mind. I think here they should have said, when they wrote the problem down, negative root 10 needs to be less than or equal to x less than or equal to positive root 10. That just gives your domain. Here, this gives your domain. T cannot equal negative 5. Any other number in the world, anything less than negative 5, yes. Anything greater than negative 5, yes. But not negative 5. Okay. Now, with that in mind, we got that out of the way. What could make this rational expression, and we call that a rational expression because it's the ratio of two polynomials. What will make that rational expression equal to 0? That's really what we're interested in here. We've already seen that the denominator can't be 0, ever. Cannot be 0. But guess what? The only way to make this ratio equal to 0 is if the numerator is equal to 0. So all you have to do here is say 2t minus 3 is equal to 0. Because if that numerator is 0, it doesn't matter what the denominator is, as long as it's not negative 5. It could be anything in the world. It could be 4 million. But if that numerator is 0, 0 over 4 million is still 0. It could be negative pi thirds, the numerator. But if that denominator, the denominator could be negative pi thirds. But if that numerator is 0, 0 over negative pi thirds is still 0. That numerator is all that matters here. So we solve this equation for t. What would you do first? If I could get my pen to show up here. There it is. Solve for t. What would you do? Anybody? Add 3 to both sides. That makes that go to 0. You get 2t is equal to 3. And then you divide both sides by 2. These divide away, and you get t is equal to 3/2. That is your one and only 1, 0 for that function. Okay. Now, if we were to graph that one, and I don't know if they will or not, let's go and watch them to see if they do. We haven't gotten that far in the course, but I think they'll still graph it for us. Let me just give you a quick and dirty of how to graph this. Uh, if this is your graph, I don't draw graphs too well freehand. Um, we know t cannot equal -5. 1, 2, 3, 4, 5. At -5, you have to put in what they call a vertical asymptote. All along that vertical line, t is equal. Oh, get out of there. Sorry about that. I must have hit something on the command line that made that happen, and now I can't get my cursor to show up. There it is. It keeps flying all over the place. Oh, I know why. All right, here we're back again. This is the line. That line right there is t is not equal to -5. That's why it's dashed. It cannot touch it. Okay? Now this is getting way ahead, but you also have what they call a horizontal asymptote. You get that by looking at the ratio of the leading terms there. 2t over t is 2. So do y is equal to 2, 1, 2. That gives you what they call your horizontal asymptote. Okay? Now, you also just found out that when t is equal to 3 halves, your see x and y, these are h and t. T is the independent variable now, and so this should not, well, that's the other problem. I had that one right. This should be your h of t up here. Okay? Now, we saw that t equal 3 halves. So there's 1, 2, so 3 halves is right in between. There's a 0. Well, we know where this is heading. This is heading toward the horizontal asymptote this way, and after a while, it's heading to the vertical asymptote that way. That means over here, it's going to be something like this. Well, guess what? That's not what we're concerned with here. There's our one and only one, 0 for this function. Let's see if their graph looks anything like this, if they bothered to graph it. Let's go back and see h of t. This is number C. Yeah, here it is. Set h of t equal to 0. So 2t minus 3 over t plus 5 is equal to 0. Okay? Now, they didn't say it, but I say it. T can't be -5. Okay? To make, and what they do, it's an okay thing to do, but it's usually not the way. They multiply both sides of the equation by t plus 5. That wipes it out here, and 0 times t plus 5 is still 0. Okay? So that's the other way of saying the only way that rational expression is 0 is if that numerator is 0. So they got it a different way, got the same thing. Then solve that for t, and that gives you 2t is equal to 3, adding 3 to both sides. Dividing by 2, you get t is equal to 3 halves. Okay, let's see if they draw it for you. They drew part of it for you. Okay, the 0 of the function is t is equal to 3 halves. In this figure, here is part of the graph of h, and it shows that as the y-intercept, or the h-intercept, I guess you would say. Now, what they don't show is what's happening down here. If you went on out here and did your -5 right here, you would see, sure enough, if you did a vertical asymptote here like we did, that's exactly where this is heading here. And if you did the horizontal asymptote like we did at y is equal to 2, I don't know why they decided to name that y, but you could if you wanted to. I would have left it as h. This is heading to that one. So if this one's over here, the other one would be here. Now that's a pretty ugly drawing, but you got what it is. It mirrors across that intersection right here. What happens down here is happening up there, opposite sides. Okay. Way more than you needed to know for the problem. They did draw this part, but they didn't tell you how they drew it. But that's how they drew it. All right. Okay, which one's this? That really ugly one. This one? Okay. Now, yeah, I wish I could erase the B part, but on this screen I can't erase, not with this thing. Or I haven't figured out how to yet. Once I go to the, what do you call it, whiteboard, I can erase that one sometimes, but not always. So it's a little limited. The old computer I had was had a Wacom built into it. This is a Wacom pad. And this is exterior, so you can't do quite as much with it. But the old one had a writable screen. Oh, and it was just wonderful, but it died. Uh, and I couldn't, I tried resurrecting it. It got back for a couple weeks and died again. So I figured it's over with. It was old computer, but it had a wonderful writable screen. All right, that was the B. Here's the C. Any other questions about this one? And this, by the way, is now called the t-intercept because your horizontal axis is t. Same as x-intercept. Horizontal intercept is 3/2 0. Your 0 for your function. That's what this is saying. The y, or the h of t, is equal to 0. That's what it means, 0 of the function. So your x value is the 0 for that function. So just a quick review. This one had 1. This one had 2. The first one we did last time had 2. You can usually tell by the degree of it. This is a polynomial function degree 2. It can have up to 2 zeros. Can't have any more. May have fewer. May only have 1 or none. But it can't have more than 2. This one's a square root, but inside there is a square, so that could have up to 2. No guarantee that it would, but it could. And sure enough, this one had 2 as well. This one, however, the numerator is what's going to govern the show here. The denominator tells you where you can't go on the domain. This tells you where your zeros are going to be. That's linear, 1 and only 1 root. And sure enough, that's what we had here. 1 and only 1 root. All right, good deal. Any questions? Sort of beat that one in the ground, didn't we? So let's see. After every example in the book, there is a checkpoint. Please do the checkpoints sometime as soon as you can out of the class, after class. All right, and by the way, if you can't get a checkpoint to work out, that's something else you can send to me. I cannot get the answers they got. And remember, the checkpoints, their answers are in the back of the book, but their audio video solutions are at larsonprecalculus.com, that third website. Okay, so now let's talk about increasing and decreasing functions. This is something you almost, at least at this stage of your game, have to draw a graph to determine. Not completely, but it's almost true. The more you know about the graph of a function, the more you know about the function itself. So here's a function here. I don't know what that function is. I'll tell you now, it's a piecewise defined function. It's defined one way here, another way here, and yet a third way here. But we've run into those before. Remember, we put the brace there, put this one for anything x is less than 0, this one between 0 and 2, this one between anything beyond 2, greater than 2. Okay? Piecewise defined function. We've seen those before. Now, when you're talking about what the function's doing, be sure, I don't think anyone new has come in. That seems like the same number we've had before. But every now and then someone has to leave the class. Either phones mess up, the computer messes up, or you're at work or something, and then you come back in. So I always check to make sure someone's not trying to come back in. Doesn't look like they are, so that's out of there. Always, you move on the horizontal axis from left to right. Let the x's go from very small x's to larger and larger and larger and larger and larger x's. That's where you're heading, left to right, low to high, okay? And as you do that, what is the y doing? What is the function doing? Over here, anything between negative and infinity, well, no. This has a dot here, so that means this function is only defined to -2. So the only domain here is -2 to 4. That's all we're interested in. Now, if that just continued on past the dot, then we assume it goes to -infinity. This one doesn't, so we end at -2. So at -2, and from -2 to 0, the function is strictly decreasing. It's getting less and less every time you go further and further to the right. But then when it gets to x equals 0, until it gets to x equal 2, it's a constant function. It's not decreasing, it's not increasing, it's constant. So this is called a constant function between 0 and 2. Always you refer to the x values left or right here, and then say what the y value is doing here. Okay? Then from 2 to 4, and that's the remaining domain of this function, it's strictly increasing. Okay, I don't know what the ting was about, but let me make sure I don't have anybody else trying to come in. Nope, no one else trying to come in. Sorry I have to do this. I just don't want to leave someone out there in the waiting room. And I don't know if you can see it, this thing that sometimes shows up and sometimes doesn't, fades out. If someone's trying to come in, it will try to block me from seeing it, and I do not know why. This is some mixture between Zoom and PowerPoint. I don't know why this happens, but someone tries to come in and it tries to cover their name, so I can't see them. I don't know. It's trying to protect itself. I don't know what it's doing. So that's why I usually will check. So anyway, that's what's happening. That's how you define decreasing, constant, or increasing functions. Okay? They say up here increasing and decreasing functions. You can also have a constant function. You can also have a function that's not defined. Okay? We saw one of those earlier. Yeah, let me turn back. It's not too many slides away that we saw that. Well, it won't advance or retreat here. Okay. Oh man, they left that one out. In your book, example 4, they left it out here. Did we do example 4 in class? I know we did. No, I'm sorry, it wasn't example 4, it was example 2. Back when we read vertical line test. Did we do example 2? I think we did. I'll show it to you. If we didn't do it, we can go back and do it real quickly. Here's example 2. That first one failed the vertical line test, meaning it wasn't a function. If you had defined the function only to be the top half or the bottom half, that would have been a function, but not with the whole parabola there. This one, no matter how many times it ups and downs this way, vertical line test passes, so it is a function. This one, however, notice it was defined. It looked like anywhere from negative infinity to 0, but then it wasn't defined between 0 and what's that, 2? Yeah, between 0 and 2, and then it is defined from 2 to positive infinity. So this was a decreasing function here, increasing function here, not defined in between 0 and 2. So there are actually four possibilities: increasing, decreasing, constant, or not defined. Okay? And I remembered seeing that in the book. I wanted to show you there are other possibilities besides the one they said. They said increasing or decreasing. That's only half the story. Well, it's usually more than half. Okay. Now, they showed constant here. They didn't show, except back there, the not defined one. Okay. Beat that in the ground. So here's the formal definition of what we mean by an increasing, a decreasing, or a constant function. They can manage to make it sound really complicated, but really this says it pretty well. A function f is increasing on an interval when for any x1 and x2 in the interval. Okay, was there a question? Okay. Is that a question to me or someone else? I think, Janae, your microphone's on. Did you mean that for me? No problem. Yeah, things happen, I know. So for any x1 and x2 in the interval, f increasing on an interval, for any x1 and x2 in the interval, x1 has to be less than x2. x1 to the left of x2, x2 to the right of x1. x1 less than x2, that implies if it's an increasing function, the f of x1 is also less than f of x2. For the function to be increasing there, that means f of x2 must be greater than f of x1 if x2 is greater than x1. Now, function f is decreasing on some interval. For any x1 and x2 in that interval, when x1 again is less than x2, that implies that f of x1 is greater than f of x2 because the one on the left has to be greater for that to be decreasing to the one on the right. So that's the definition for when it's decreasing. A function is constant on an interval when for any x1 and x2 in the interval, and it doesn't matter which order they are in this case, x1 is f of x1 is equal to f of x2. If that's true everywhere in the interval, that means it's a constant function. It's never changing, not increasing, not decreasing. It's constant. Okay. Yeah. All right. Are we ready for example 4? This, by the way, is on page 52. It says use the graphs to describe the increasing, decreasing, or constant behavior of each function. Someone tell me what you think this first function is doing. Is it increasing? Is it decreasing? And then what interval? Anybody? Okay, Janae, I think your phone is still on. Okay, no problem. Tommy, did you say something?
I thought it was
Increasing everywhere. You're absolutely right. The only question might be right here around 0. It does look like it flattens out, but if you were to take a point really close to 0, like 0.1 or negative 0.1, let's say, negative 0.1, cube it, you get negative 0.001. Okay, that's awfully close to 0, but it's still negative. If you take a point just to the right of 0, like 0.1, and then you cube it, that would be 0.001. So that would be slightly positive. So yeah, this is increasing. Even when it looks pretty flat there, it is slowly increasing. Up here, by all means, it's increasing everywhere else. So that's increasing everywhere. Perfect. Got it on the nose. How about this one? How would you describe its increasing, decreasing, or constant behavior?
It's increasing twice and then it goes down once.
Okay, so it's increasing from, and since there's no dot here, we're going to make an assumption that it keeps increasing forever here. So that's from negative infinity up to negative 1. You always refer to the domain by your horizontal axis. So it's increasing from negative infinity to negative 1, and then it's decreasing from negative 1 to positive 1. And did someone come in? I don't think so, but let me check. Nope. Okay. I want to make sure. So it's decreasing from negative 1 to positive 1. And then after that, like you said, it's increasing again from positive 1. And since there's no dot up here, we assume it goes to infinity on x. And it, by the way, is going to infinity on y too. Okay. So yeah, you got it right. Increasing from negative infinity to minus 1, decreasing from minus 1 to 1, increasing from 1 to infinity. Now, when you're talking about these, it's okay to leave off the less than or equal to. You can just say negative infinity to minus 1. You can put a parenthesis there. You could put less than. You don't have to put the equal to. They do over here, but it's not necessary. They do right here, but that's not necessary. So let's go to the C one. How would you describe its behavior? Constant between 0 and 2. Always give the interval. But it's doing what over here? That one's increasing from negative infinity to 0, constant from 0 to 2, and what's it doing over here? Decreasing from 2 to positive infinity. Perfect, perfect, perfect. Now, the piecewise defined function, linear function here, you know that is going all the way from negative infinity to 0. This is the function, t plus 1. You can tell there's a y-intercept there, slope of 1. Okay, it's 0. I'm sorry, it's 1 from 0 to 2. Constant, not changing, not increasing, not decreasing. It's 1. And then from here on, it has a negative slope. It's going down 1 for every 1 it goes over, so a negative 1 slope. And if you had drawn it, extended this up, it would have had a y-intercept of positive 3, so that's where the plus 3 comes from. Linear function, and it goes from 2 to positive infinity, decreasing. Excellent. Y'all are good at this. Any questions on that before we move? Always give the boundaries of your interval with the x values, and you're describing the y value. Is the y value increasing, decreasing, or constant? But you give the boundaries as being the x values that define that interval. Those, yes. Okay. It won't advance until I click the screen. Okay, here we go. So the first one was increasing over the entire real number line. Tommy got it absolutely correct. Second one, the function was increasing from negative infinity to minus 1, then decreasing from minus 1 to 1, and then increasing again from 1 to positive infinity, just like we said. Several of you said that one. And then the third one, the function was increasing. Whoops, here comes somebody in, and I can't see because it blocked it. That's Janae. So Janae must have had to go out and come back in. Let's let her back in. I already marked her present, I'm pretty sure, so let me make sure I didn't fail to do that. Yeah, Janae was already marked present. I knew we had talked. Okay. So, now we're up to 23 students. Let's make sure that's right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 22. Actually, we had 24, so we must have lost somebody else. That may have been one of those dings we heard earlier when someone had to leave. Okay. Yeah. Okay. The third one was the function is increasing on the interval from negative infinity to 0, then it's constant from 0 to 2, and then decreasing from 2 to positive infinity. The intervals are always your x's. The description here, increasing, that's referring to the function, which is a y, the vertical axis. That's what's happening there, constant or decreasing. So what you're describing is what's going on the y-axis, but during the intervals on the x-axis. Okay, it won't advance until I click the screen again. Okay, to help you decide whether a function is increasing or decreasing or constant on the interval, you can evaluate the function at several values of x. However, you'd have to do an awful lot to make sure you got them all, so that's usually not a good thing. When you do get to calculus, and I don't know, is someone behind that? I don't think they are, but let me check. No, I don't see anybody. Okay. However, you need calculus to determine for certain all the intervals in which it's increasing, decreasing, or constant, and that comes from what they call the first derivatives. Now, D is in the way here a little bit, so I'm going to scoot you to the right just a tad. Okay, and the rest of you too. Okay, you can't see that, but it's just blocking a little bit of my screen. Okay, and again, it won't advance until I click on it. Now, the points at which a function changes from increasing to decreasing, or decreasing to increasing, or increasing to constant or decreasing to constant are helpful in determining sometimes what the relative minimum and relative maximum values of the function are. So here's the definitions for this. Definitions of relative minimum and maximum. A function value, f of a, that's going to be a y value, f at some value x equal a, is called a relative minimum of f when there exists an interval, again, x1 and x2, around that value a. A is somewhere in here, x1 is over here, x2 is over here. Somewhere in that interval, x1, x2, and a is in between. Okay? Some interval that contains a, and if x1 is always less than the x, okay, I think it's Shamari. I think your microphone's on. Shamari, I think your microphone's on. No, it's not Shamari, sorry. Who was Daddy? Remind me. I can't remember. Whoever Daddy was, your microphone's on. That was I know exactly who it was now. Yeah, Ladarius. That's who it was. Ladarius. Ladarius, your microphone's on. I don't know if you realize that. Okay, well, it's still on, but at least the noise is shut down. Okay, so if you have some value, f of a, okay, Ladarius, your microphone's on. Can you hear me? Okay. If you have some value x, a, okay. Ladarius, your microphone is on. Okay. If you have, okay. Ladarius, could you check your microphone? Could you mute? There, thank you. Okay. If you have some value a, the f at that a is a relative minimum when there exists some interval x1 on one side of a's here, x1 on this side, x2's on this side, a somewhere in between, some interval x1 less than x less than x2, so x1's on the left, x2 on the right, a somewhere in between. It implies that for every other x in that interval, f of a is always less than or equal to any of those other f of x's. That makes it a relative minimum. Okay? It's a relative maximum where that a in between x1 and x2 again, that is larger than or equal to any of the other x's there. That makes it a relative maximum. So if we go back to a couple of those slides that we had before, does this one have a relative minimum or maximum? No, it doesn't ever change. It was constantly increasing, so it increases, it increases, it increases. It doesn't reach a maximum and certainly didn't have a minimum. How about this one? Yeah, that point right there. -1, 2 is a relative maximum because for some region around that x equal -1, that's your a in this case, for every value on close to -1 on either side, it's always less than or equal to the value there. So that's a relative maximum. This one down here is a relative minimum. Why? Because pick some interval on either side of +1, and the f of that, if anything in there is greater than, sometimes equal to, but greater than the value at 1. That's the minimum. Now up here for this one, a little bizarre. Every point between 1 and 2 is a relative minimum because everything in between there is the same value. So that entire constant value there is a relative maximum. Oh, you're kidding me. Just when we were having fun. Of course, we're always having fun. So let's go back to where we left off. Those are our definitions. So we were going to start next time at this graph right here. So we will do that graph. That's where we'll begin next time. Let me erase my previous mark. I thought we were going to get further today, but I did too much talking at the beginning. So homework exercises here. We made some progress. Will be any of the odds, 7 or 9. Either one of those are both at Calc Chat. 9's at Calc View. Either 11 or 13, both at Calc Chat. 11's at Calc View. Any of the odds 15 to 25, they're all at Calc Chat. 25's at Calc View. 27 through 31, they're all at Calc Chat. And increasing, decreasing behavior any of the odds 33 through 39. They're all at Calc Chat. 35 is at Calc View. Any of the odds 41 to 47. They're all at Calc Chat. And then we'll pick up next time with 49. So go through 47 this time. All right. Thursday, we'll hopefully finish 1.5. We only have a couple pages, and then we'll get started in 1.6. Okay? Now, that looks like to me the first test, which is going to be a fairly short test, will probably be, I'm guessing, next Tuesday. Okay, is when I'll give it to you. We'll see how far we get in class, and if we get far enough in class, then I'll give you that test on Tuesday. You'll have at least a week to work on it. The reason I say at least a week, that gives you a chance on Thursday, if I give it to you on Tuesday, to ask questions about it. Okay. Another reason I give you at least a week, you always have a weekend to work on it if you're busy during the week with kids or work or other things like that. So you can have more time if you want, but you need to get it into me before we go to the second test, which will be at the end of 1.9. And I think things will move a little bit faster than they have the first part of the term because we've had so many issues. But so be expecting that first test sometime next week, either Tuesday or Thursday. It could happen that we get far enough along next time I can give it to you after Thursday, and that may just give you an extra weekend to work on it because I don't think we'll finish 1.6 then. Any questions? And by the way, when we have a test out there, if you don't want to have to turn in a homework problem that week, you don't have to, because I figure you're working on the test. I'd rather you work on the test than fiddle around with sending me a homework exercise. But if you get the test done and want to send me the exercise, you can do that too. But when you're working on the test, that's where I want you to put your effort. Okay? Any questions? All right. Well, then I'm going to stop. What won't count against you? Okay. Okay. Now remember, the homework counts 0 points, so it's not going to hurt you or help you either way. The only time when the homework will help is at the end of the term. If you have more, and what I do, I'll show you my thing, and this isn't up to date, but you see how I'll cover the names here. See how I put those little pluses in there? That means you turn in something. Okay? If you have more pluses than you have blanks, and on the Blackboard grade list, grade book, I think they call it there, if you turn it in, there's a 0 posted. If you don't turn it in, it says there's just no grade there. If you have more 0 posted, then you have no grades. Or if you have more pluses in my book, then you have blanks. Then at the end of the term, if you happen to be right on the cusp, not quite high enough to get that B or to get that A or to get that C, but you've turned in more homework than you've missed, then I bump you up. If you have more blanks, in other words, that's the only way it helps you. There's no penalty, there's no points. It's just if you have more homework turned in than you have blanks, then if you're all on the cusp, if you're at 85, you're going to have an 85. Okay, you're going to have a B. If you're at a 77, you're going to have a C. It can't bump you up a bunch. But if it's right on the thing that it wouldn't round to a B normally, but just a little bit more, say half a point more, then I'll give you that half point. Okay? So, yeah. But if you finish the test and you just want to work on practice a problem, or you're having problems on one, send them to me. I always want to see those that you're having difficulties with. And if you aren't having difficulties and you finish the test and want to send me one, that'll be another plus on the page. Okay? Good question. Any others? All right, well then I'm going to end the recording and we'll see you on Thursday. Same time, same station. Bye-bye.